So what we want to go ahead and do on this, I've got a unit circle here. So what we want to do is when we do this graph, now this right here that needs to be scratched out. That should be y equals -2 cosine x. That's what we're going to work on graphing without our calculator, is we're going to graph this out. Then I'll show you what you can do on your calculator to kind of check and verify this. Okay, so the first thing we're going to do is we're going to graph y equals cosine of x. Okay, now if you go to a unit circle, what do you look at on the unit circle to get a cosine? You look at what? X, good. Okay, so I'm just going to go around and highlight all of these key x values, and we're just going to write these on here. So the cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is -1. Cosine of 3 pi over 2 is 0. And then 2 pi is back here, so that's equal to 1. So that's what we call one period of the sine wave. This is 5 key points. They cycle through these points. If you went backwards with this, if you went -2 pi, -2 pi we know is clockwise, so that would be back to 1. If we did -3 pi over 2, that would be clockwise that way, so that would be 0. Negative pi would be clockwise halfway, so that would be -1. And then negative pi over 2 would be back to 0 like that, okay? So let's go ahead and let's graph that first of all. So take the graph, the blank graph I gave you, and let's go ahead and just put these on here. So we have, when we label this one, what I want you to do is label the y-axis like this. Just go up to 2 and down to -2 like that. Okay, let's go ahead and let's start by just plotting the points we just have. So we have -2 pi 1, -3 pi over 2 0, and let's see, negative pi -1. And then once you learn these graphs of sine and cosine, you can graph them real fast because they cycle through those key points. And then let's just use like a dashed line. This is not the final graph we're doing, but it will be a tool to help us get that final graph. So let's maybe label that as y equals cosine x, okay? Now that's the standard starting point of learning how to graph trigonometric functions, is how to do the basic ones. Everybody with me on what I just did there? Okay, cosine's just x values, so we do that. Now, what we learned last time is, what we're looking at is if you have a cosine x, the number in front, remember we call that the amplitude. So the amplitude is the absolute value of this number that's in front, so it's +2. An amplitude is always a positive number because it's a distance, okay? That negative is going to cause this thing to reflect, basically. So basically, here's what you do with this. All we're going to do is we're just going to multiply all of the y values. This is a good thing to write down. Multiply the y values by -2. Okay, so in this second row, when we graph -2 cosine x, just take each y value and multiply it by -2. Right, what's that going to do? It's going to stretch it, and what else? Reflect it, exactly. So it's a transformation like we've learned. So this would be 1 times -2 is -2, 0 times -2 is 0, -1 times -2 is 2, and so forth. And you can do that real quickly in your head. I'm just multiplying by -2. Okay, so that'll give me those values there. And then what we want to do is go ahead and plot those, and then that'll give us the graph of -2 cosine x. So I'm going to start here. We're going to go -2 over pi, -2, -3 of pi over 2, 0, -pi 2. And then once you get about 3 points, you can predict where they go. So the next one's going to go here, then back down to -2, and then to there, and then to its maximum, and so forth like that. Okay, so you can get these graphs done pretty quickly and then just sketch it in. The sketch of a cosine or a sine, it's a curve. It doesn't have like straight lines, it's curves that go through these points kind of like that. So that's your final product like that, okay? And you want to be able to do that without a calculator. When you go to like calculus, which is your next class, what you're going to take, you have to construct trig graphs from time to time, and you want to be able to do that pretty quickly. Okay, so let me show you the calculator part of this too. So if you'll get your calculator out, we'll go through a little bit of this with a calculator, but you want to learn how to do this with the calculator and then kind of more checking with your calculator. So what we want to do on this, I'm just going to show you how you would graph and set up a trig functions. First thing is you want to be in radian mode. Okay, anytime you do any graph, you want to be in radian mode. And then we'll just put in, go to y equals, and then just put in what we're graphing. We're going to put in -2 and then cosine of x. Okay, and then that'll get you all set up. And then the window, we're going to do just like I have on the graph here. So for your window, we're going to go from -2 pi to 2 pi. And you just use your pi key. And when you do that, all that's going to do is change it to a decimal. Then your max is going to be 2 pi. Okay, the scale is we're going by pi over 2. So if you look at the table we did, we were going by 90 degrees or pi over 2. So I'm going to put in pi over 2 here. All right, and then for the y's, let's just do like we did, -2 to 2 on the y's. And by a scale of 1 or a half or whatever, and that's it. So that's how you would get that set up. So you want to make sure you're in radian mode or it isn't going to graph the same thing. Now if you type graph, it'll give all the same points that we have, okay? But you don't want to get too reliant on your calculator. You want to use that more as a checking tool because you want to understand the mathematics behind the graph and how it relates to the unit circle and everything. That's what you're trying to get, okay? All right, does anybody have a question about what I did on that problem? Does that look like a pretty basic one? Okay, because it is. They get a little bit harder. So at the beginning here, we talk about amplitude. So just to kind of review on this, the amplitude is always the number that's directly in front of the sine or cosine. So in this case, the amplitude is 1. In this case, the amplitude's 5. And then the next one, what is it? It's 5. It's still positive 5. Don't forget that it has to be a positive number, so that amplitude's on that is 5. So what you want to get down in your head is if you graphed sine of 5 sine x, what would it do? It'd stretch it. So it would have a low point of -5 and a high point of 5. Does that make sense to everybody? Okay, that's what the amplitude does. Okay, and then the number directly in front multiplies each y value by a. That's what we did on the last problem, is we took the first row, multiplied the y's by -2 to get that result. So that's how that goes. Okay, so the next thing we'll talk about is what we talk about as a phase shift. A phase shift is just a transformation that moves things left or right. And we're going to take this to, we're going to look at the function now like this with a sine and cosine. So the amplitude is still a, like we talked about, but the phase shift is going to be this number b. Okay, and it goes like this. It works the same way we learned about transformations. If this is x minus b, that takes you to the right. And then if it's x plus b, that's going to take you to the left. Okay, that's no different than having like a quadratic function. Like if you had y equals that, what would that do? The parabola would go 1 to the right. So it's exactly the same thing. Okay, we just have phase shift is what we call that. Then if you have d, d is up or down. So like if you had a parabola, like this is a parabola, that would take you to the right 1. That 2 would take you up 2 like we've learned, so it works the same way on any function actually. The d is going to move you up or down, okay, like that. Plus d is up, minus d is down. All right, does that make sense? It's all the same, okay? All functions work exactly the same way. So before we get into graphing, let's go ahead and let's just look at this then. So first of all, what is the amplitude on number 11? That's the number in front of the sine, so that's 1. Okay, what's the phase shift? Which number represents it? Pi over 2. Which way? Left. Okay, so we're going to say pi over 2 to the left. Typically what my math lab does, not all textbooks do this, but I want you to know that it goes to the left. You don't have to put negative pi over 2, but I think our textbook and most textbooks require you to do that. What I care about is it's pi over 2 to the left. You want to know that, okay? Then the next one has the same amplitude. That's 1. This time the phase shift is pi over 2. And this time it's to the right. Okay, so you got to be able to recognize that stuff before you can do the graphing. Okay, so just think of that as, think of an amplitude as a vertical stretch shrink, and a phase shift as a left-right transformation. Okay, this one, what I'm going to do is I'm going to do a phase shift, a couple of problems that just have a phase shift. A couple of these problems I'm going to change also, but this one I'm just going to focus on this one with doing a phase shift and kind of show you what you want to do. First thing that you always want to do, if you're graphing a sine and cosine, you want to identify everything. So the period of this, the formula for the period is 2 pi over b. Or in this case, hold on, I'm not going to use b because the textbook doesn't do that. Some textbooks do. So it's always just going to be whatever that number is in front of x. Okay, so if I put like an e there or something like that, like in front of x, then that would be how you would get the period. Now, what we haven't learned what happens when the period changes yet. We're going to get to that tonight. Okay, so the period is just 2 pi. Anytime that the number in front of x is 1, the period's 2 pi on a sine or cosine. That's all we've talked about so far. If you put a number in front of x, then it starts doing this. It starts doing a horizontal stretch or shrink, which is what causes the period to change. We'll get to that in a few minutes. Okay, what's the amplitude just by looking? 3. What's the phase shift? Negative pi over 2, and that's going which way? To the left. Okay, is there anything that's causing this to reflect over the x-axis? No. Okay, what would you see in order for this to reflect over the x-axis? A negative 3, right? Okay, if it was negative 3, then yeah, it would be a reflection. Okay, all right. So what we're going to try to do on this, go ahead.
So why is it negative pi over 2 if it's plus pi?
Because it's going to the left. What happens is the general form is cosine x minus b. So I'm really writing this as x minus negative pi over 2. Okay, that's why I write that as negative pi over 2. That's the standard form. Okay, so what we're going to do on this one is we're going to do this in a couple of stages. The first thing that you want to do on this is we're going to go ahead and we're going to graph y equals 3 cosine of x. Now, you don't have to do this in like 5 stages. I always like students to be able to do this at the most maybe 2 stages on your paper. That's it. It just gets too confusing. So if you're going to do a cosine, this is basically what we're going to do here. All right. Now, you want to get to a point where you have the values memorized pretty good. Let's just go ahead and scale our y-axis up to 4 and down to negative 4 because of that amplitude being 3. Okay. So this is basically what you want to do. Now, you don't need to put these dots on your paper. This is what I want to teach you how to do. If you do a cosine, if you look at my unit circle, the cosine of 0 is 1. So I'm just going to lightly put a dot there. You don't need to do that. You just pay attention to what I'm doing. If you go to pi over 2, then the x value is 0. If you go to pi, then you're at negative 1 and so forth. Now, it's to your advantage to memorize these points on the cosine. The easiest way to me to do that is if you can just remember that the cosine starts at 0, 1 and cycles through those points, then you can do that super fast, okay? Anytime you forget, you go to the unit circle, okay? Now, what I want to do from here is, what is this 3 going to do to that original graph? What did we just learn? Okay, it stretches it. The amplitude changes to 3, so what happens is you want to put these points on here now. This has a y value of 1, so 1 times 3 is 3. You definitely want to put a dot there, okay? All right, this point is 0. 0 times 3 is still 0, so that's a definite dot there. Where does this point go? Negative 3, right, because its y value is negative 1. Negative 1 times 3 is negative 3 like this. So see, I want you to get to a point where you can do the amplitude all at the same time, see? Okay, you don't need to write down 2 graphs. You just need to understand that that changes the y values by multiplying. Okay, so you want to go ahead then and get these points here. Okay, like this. All right, and then that'll give you the graph of y equals 3 cosine x. All right, so that's how I started that problem, as I did that, and I'm going to erase some of those original dots. Okay, everybody with me there? So you want to know how to do like something like 3 sine, 2 sine, 2 cosine in just one step. It's not that hard to do. Okay, now what we're going to do is this is going to phase shift. So what we're going to do is, since the phase shift is pi over 2 to the left, you can start anywhere you want to and just move that point pi over 2 to the left. So if we started here, that point right there is going to move right over there, and that's where that dot's going to go. Okay, and if you take this point and move it, it's going to go there. And the nice thing about doing trig functions is once you get 2 points, you can predict where the rest of them go. Okay, so this is just going to go like this. This point's going to phase shift there, and so forth. Then you can go ahead and just kind of start putting it together. And you can pretty well tell that the next point here is going to go down to its minimum. Okay, and then the next point is going to go the x-axis. And then the next point goes to its maximum. And then like that. So all of the points are getting phase shifted pi over 2 to the left. Okay, so once you get like 2 of those points, then the rest of them are pretty easy to get. Okay, so that's how that goes. Does that make sense to everybody? I did that? Okay. Now, you could actually do this problem with a little practice. You can do the whole thing in your head if you just start at the phase shift, okay? So I want you to make sure you have that down. Then I'm going to erase this, and I'm going to show you the way I would like you ultimately to be able to do this problem, okay? Has everybody got the graph down? And with me on that, okay? So let me show you what you want to learn how to do, seriously, because you want to be able to get these graphs very fast and very efficiently. So if you remember, the cosine starts at its high point. If you just remember that, okay, it's a good idea to just start at your phase shift. So this is a good thing to write down. When you have a phase shift, that's where you should start, is at that particular point. Okay, so I'm going to go through and I'm going to do that then. So what I'm going to do is take this point and I'm going to move it over here. It phase shifts over there, but the amplitude takes it up to 3. Okay, and if you got that down, then the rest of it, you're going to know how it goes, okay? Because the rest of it, what's it going to do? It's going to go down to the x-axis, then it's going to go to its minimum, and so forth like that. So it just cycles through those points, so you want to be able to do that problem like that, okay? You don't want to have to go through the steps unless you feel like you need to, okay? So that's the idea. All right, let's go to 14. And let's do one more with a phase shift, and then I'm going to try to do some with period changes a little bit here tonight too. Okay, so with this one, first of all, the period on this is 2 pi. We haven't talked about the period changing yet. That's because the number in front of x is 1. Nothing's changing. The amplitude's a half. The phase shift is negative pi, so that's going to go to the left. And this time, there's still no reflection over the x-axis, so we don't have that yet, okay? So this time, what I want you to do on this is, I'm going to show you, try to show you how to do this just in one step, okay? And this is really what you can do here, is you can always start the problem. Since you're graphing a sine, you're looking at these y values right there, okay? And you want to try to get these memorized as fast as you can. So the very first point on a sine is right there. Okay, the next point on the sine is, and we need to probably, let's get our y-axis put together. Let's call that 1, and call that -1, and then let's call that a half, and then call that -a half. So we want to get that put together. Okay, so I'm just going to put like 2 dots on here, and then the rest of it you could reason out. So okay, so the first dot is 0, 0, then you got pi over 2, 1 like that. Okay, now I'm not going to have you connect those dots or anything. We're just going to do this. So one of the things I said is if you have a phase shift, you want to start there. Okay, so that point right there is going to move where? To there, right? Okay, so everything's going to move over two big increments right there. So that point's going to move there. This point right here is going to move there and so forth. So again, if you can get 2 dots to start with, you got it made. So let's just move this dot to there, and then let's move this dot to there, okay, like that. All right, now that gets us 2 dots, but the next thing you want to do is, what is that 1/2 going to do to that point? What does that 1/2 do to that y value?
Drop it down.
It drops it down, but more specifically, it multiplies that y value by 1/2. So 1 times a half is a half. Okay, so it's shrinking. It's not moving down. It's really shrinking is what it's doing. So that point right there moves down here now. Okay, and then this point right here, it has a y value of 0, so a half times 0 is still 0. So that right there is two dots on your curve. Okay, and so you can do that if you start at the phase shift. That's your point number 1. Then your point number 2 is going to go high on a sine. Use that amplitude, then you got it made. So if you can reason out those 2 points, the rest of it's easy. So here's what you do from here. The next point, what's it ready to go to? Back down there. Okay, back down to the x-axis. Then where? to the minimum, okay, back to the minimum, okay, so it goes like that, like that. There's one period right there, okay, that's how you can do that. Now, if you need to do steps, but if you can get it to doing it this way, that's a little bit better and it's a little bit more efficient, yeah.
Because it's 2 pi, even though it shifts, the graph doesn't actually look real different.
No, the graph looks the same, it's just everything got moved over. It hasn't affected or impacted the general shape of that wave. Okay, it's done two things. It's shifted it and shrunk it. That's all it's done, okay? And then from there, you can go through and put the rest of the points on there if you want to. Then that would give you what you've got there. So that would be what your graph looks like, okay? So do it in stages or do it that way, okay? You can do that. If you have a phase shift and an amplitude, you can generally handle that in one step with a little bit of practice, okay? Okay, so let's go to the next one. And I want to do this, and then I'm going to have you, we're going to work a little bit with period changes also here in just a minute. Okay, so with this one, the period is still 2 pi. We're not to the point where we've changed it yet. The amplitude's 3. Phase shift is pi. This time it's right. Just for fun, not that it's fun, but let's change that 3 to -3. Just do that, because I want to give you a problem that has everything in it. So yeah, this one is going to reflect over the x-axis, okay, when we do that, all right? Now this one's complicated enough. You could do this in one stage if you were really skilled with it. I'm going to probably have you do this one in 2 stages. So I'm going to show you what I'm going to have you do. What you generally want to do is work inside out on these problems, okay? So what I'm going to have you do is we're just going to graph this, and this is going to be a dashed line. So let's write down that we're going to graph y equals sine x minus pi. Now that's the way I'm generally going to teach you how to do these problems, is inside out. Anything that's outside of the sine function, that affects y values, so you just do that last, and you can do it all in the same step. That's what I'm going to teach you how to do, okay? And then the final product, I'll do this like in a different color. We're going to do y equals -3 sine of x minus pi plus 4 like that. So I want to try to get you to do these, the most advanced ones, in 2 stages. Go inside out, okay? If there's a phase shift, deal with that first. If there's a number in front of x, deal with that all the same. Then everything else, just deal with it in the last step. Okay, so here's what we're going to do. First thing I'm going to do is, since we're graphing a sine, we're looking at these y values on the unit circle. All right, so the first dot is that. Okay, the sine is 0, 0. Okay, where is that going to phase shift to according to this problem? Pi. So that point's not going to go there, it's going to go there. Okay, that's it. So you always want to start with that center point like that. Okay. Now, what we want to go ahead and do on this for our y-axis, let's go ahead and we're probably going to have to take this 1, 2, 3, 4. We may have to go all the way up to 7 and down to 7. So I'm just going to kind of extend this a little bit. And that'll be good enough. You'll see why here in just a minute. Okay, so I'm going to take that all the way down to -7 like that. Okay, so that's that. The second point on a sine is the point 0, 1. Well, that point is going to phase shift over there. Okay, so what I've done is I've taken the first 2 points on the sine wave, then I phase shifted it. Okay, is everybody with me there? Okay, now I'm going to erase those 2 things, and then I'm just going to fill in the rest, okay, because the rest of it's predictable. From here, it's going to go there, and then you're going to have a minimum there, like that, and then just keep cycling through those same points over and over again until you run out of room. And then that will be the graph of sine of x minus pi. And that's through 2 periods, okay? Now remember, when I'm talking about a period, I'm talking about 5 key points. So this is like 1, 2, 3, 4, 5. Okay, that's your key points. All right, so what's happened is the sine wave has phase shifted over to the right pi. All right, is everybody with me there? Okay. Now, watch how I do the next thing, okay, because you can do this in your head. What we're going to do is this, what this does is this multiplies, write this down if you need to, you multiply y by -3, and then you just add 4. And we're going to do this in our head. I'll write down a few of the things that I'm going to do, and then once you catch on, you'll just start doing this in your head. Okay, right now, let's start with this point. The y value is 0. So we're going to multiply that by -3, then we're going to add 4 to it. So where does that go? That goes to 4, doesn't it? So that point now is there. Okay, so that takes care of your first point. All right. Go to this one. This y value is -1, so you're going to multiply it by -3. That's the amplitude and the reflection taking place. Then add 4 to it. So that's going to end up being 3 plus 4, so that's going to be 7. Okay, so this point here is going to move all the way up to 7 like that. So far we've got those 2 points. Now, we're going to keep going, but you can actually just start filling them in now. I'm going to go to this y value. That y value is 3, so -3 times 0 plus 4, that's just back to 4. So that point is now there. Okay, and then we're going to go to this point. It has a y value of 1. So 1 times -3 plus 4, that's going to be equal to 1. So that point is there. And then from there, I think you could predict where the rest go, right? Okay, so the next one at 2 pi, where's it ready to go back to at 2 pi? It's ready to go back up to 4. Now right there you have a period like that. Okay, that's 5 key points right there. A lot of times I just have you graph one period. The theory is if you can do one period, you can do as many as you want to. So that's the idea. So once I got that inner part done, then I just take every y value and do that arithmetic. Okay, that's easy to do it that way. Okay, because that way you can do this always pretty much in 2 steps. Did you guys follow what I did on that arithmetic or not? Okay. You got a weird look on your face. You okay?
All right, go again.
Okay, all right, that's fine. Okay.
You didn't do the reflection.
I did, okay, and what you're not seeing is this. See, what's happening is the 3 is stretching this, right? But then it's reflecting it. So this minimum turned into a maximum.
Okay.
This maximum turned into a minimum.
Okay.
Yeah, the -3 did reflect everything. It's a little hard to see at first.
Okay.
See, what's going to happen to this point is it's going to reflect.
Because you're still not starting at 0, you're starting at pi. Okay.
Right, yeah,
Yeah,
that's it.
that's
Okay,
fine.
all right, are you okay? You said do it again or something, you okay?
You said the arithmetic.
Okay, so the arithmetic, what I'm doing is, and I'll do a couple of more of these again. Right now that y value is 0, right? Okay, so the graph is -3 times the sine x plus 4, so I'm doing that y value times -3 plus 4, and that gives you 4, so that's why that point goes there. Okay, this y value here is -1, so what I did is -3 times -1 plus 4 is 7, that's why that point moved to 7. Okay, and you can see this thing got reflected, and then it got moved up. Okay, that's what happened. Everything got stretched by 3, reflected, and moved up 4. There's your final answer. Okay, all right, are you guys with me there, what I did? Okay, that's just the way I teach it. It's just as easy to teach you how to get the inside part and then just do the arithmetic. Okay, and that way you're going to get your points where they need to go. Okay, all right, now let's see. The next thing I want to do is if you'll go, I'll talk about, I'm going to go through some of this music stuff because I think it's interesting, but I'm not going to do that right now. Go to like the back page of the handout if you would, because I want to go through 2 more examples that I'm just going to have you write down, and you need to write these down. So I just do this like on the back or just a piece of notebook paper, I don't care. So let's do a problem like this to start with. Let's do y equals the sine of 2x. I'm going to kind of focus on that, and then I'm going to do another example. I'm going to do y equals, and I'm going to do like -4 cosine of pi x. Okay, so I haven't shown you how to do these yet, and I didn't put these on the handout. I forgot to do that, so we just need to write these down to learn how to do these, okay? Because this is going to put it together, and then I'll do one last problem where we put everything together on the sine and cosine, okay? So what we're looking at is we're looking at this, y equals a sine, and I'm going to write it like bx, like that. I want to focus on this form right here. We haven't looked at what happens when you have a number in front of x yet, okay? So let's write down just a couple of things on here. The amplitude on this problem is 1. The period is now where it's different, okay? So the period, you always take 2 pi and you divide by the number that's in front of x. Okay, so you do that, okay? So the period, this is worth writing down, is 2 pi over b. That's really the absolute value of b, because a period's always positive, okay? So what we're going to do is we're going to do this. That's going to cancel out. So you're going to get the period is equal to pi like that, okay? Now, the next thing I want to show you how to do is how to do an increment of the x-axis. Okay, and what you always do on this is you always do the period, you do 1/4 of it. So you either divide it by 4 or think of it as being multiplied by a 4th. Okay, so you just do that. The reason you break it up into 4 is because there's 5 key points, and this is really going to represent 4 spaces, 5 key points. Okay, so what we're going to do is on this increment, the period is pi. Now you want to divide that by 4. Okay. And then that's going to tell us how to do the x-axis, all right? Now, what I want you to do next here is we're going to go ahead and we're going to start working on doing a graph on this now. So just kind of draw yourself out just kind of an xy axis. Then I'm going to show you how to do this problem. And basically, you'll be able to do this in your head, okay? So what we want to do first of all is the increment means this. It just means your x-axis, this is what you're counting by, okay? Like all the problems we did so far, on the x-axis we had pi over 2, pi, 3 pi over 2, and 2 pi. That's going to change now because those key points are in different places. So I'm just going to start counting this out. You just do this in your head. 2 pi over 4, 3 pi over 4, 4 pi over 4, like that. And that's as far as we're going to go because I'm only going to have you graph one period of these like this, okay? So what we're going to do then is we're going to go to the x-axis. The first first key place is pi over 4. The next one is 2 pi over 4, but you want to reduce that down to pi over 2. Okay, you want to write these in a reduced form. Okay, then the next one is 3 pi over 4. Okay, then the next one is pi. Okay, now let me explain why I had you divide by 4, because this is important. This is the whole key to doing this. There's 4 spaces there. 1, 2, 3, 4. What's pi? Pi is the period. So if you count this out, we're going to have 5 key points. We're going to have 1, 2, 3, 4, 5 key points. That's why I'm doing that, okay? So anytime you have a number in front of x, that changes these numbers. It doesn't change anything else, okay? So what we're going to do with this then is I'll show you how to get the rest of this, and I'll show you why this works. So let's just put a 1 there and a -1 there. Okay, so this is what you basically want to try to remember here. Now, you don't need to write this graph down. I just want to put this on here to refer to this. If you were graphing y equals sine of x and not sine of 2x, then basically this is the way it would go. You don't need to write this down unless you want to. But what would happen is if you graphed a basic sine wave, remember it starts at 0, 0, goes to its high point, and then cycles through those 5 key points, okay? What happens on this problem is those y values are not changed. The only way you can affect the y values is to put a number in front of the sign or do like an up-down thing there. So these stay the same. So that goes there, this goes here, there, and so forth like that. That's what your graph looks like, okay? The y's did not change, it's the x's that changed. Now I'll explain why that is, because the only way you can really wrap your head around this is just to plug in a couple of points and check it, okay? So again, what you're doing is that basic graph is the same. The only thing it changes is these things, not the structure of the points or the y value. If you want to change the y value, what do? You put a number in front of the sign to stretch or shrink it, right? Or you put a plus or minus there to move the thing up or down, okay? So what happens is when you have a number in front of x, that affects these numbers. Okay, it tells you that the 5 key points are now in different places, okay? All right, now I'm going to erase this little graph here, but I want to show you this and pay attention to this because this is how you're ultimately going to make sense of this stuff, okay? So I'm just going to plug in a couple of points. You can write it down if you want to or just watch it. It doesn't matter, but I'm trying to get you to a point where you understand why what I did worked. Okay, so what we're going to do is we're graphing sine of 2x. So I'm going to graph sine, work out sine of 2 times 0. Okay, well that's the sine of 0, and the sine of 0 is 0. So that has a y value of 0. Okay, if I go to pi over 4, I'm going to do the sine of 2 times pi over 4. Okay, 2 pi over 4 is pi over 2. What's the sine of pi over 2? When you're at pi over 2, what is the y value? 1. Okay, so that's equal to 1. Okay, so that's it. Okay, I'll do it one more time. Let's do pi over 2. So if I do 2 times pi over 2, the 2's cross out. That gives you sine of pi. And you want to do this in your head. When you're at pi, what is the y value on the unit circle? 0, right? Okay, so it matches that y value. Okay, and you can always tell you're right by checking any point you have on your graph and plugging it in, and it should work. Okay, so that's the way you handle something if it has a period change. Okay, let's do one more like that. And then I want to probably do one more where we try to put it all together here, and then that'll finish us up here. Okay, so what I want to look at here is the same kind of thing. We want to work with the amplitude. So the amplitude is 4. Remember, that's the absolute value of that number, so that's 4. And what's that 4 going to do to your cosine? It's going to stretch it, right? And then what's the negative going to do? Reflect it, right? Okay, so we know that. Now this is going to change the period. Okay, so the next thing we want to do is we want to do the period. So the period, we're going to do 2 pi divided by the number in front of x, and the pi's are going to cross out. That's a good thing if that happens too. It makes the problem easier. Okay, so the period is 2 units is what we're going to work with. Now we're going to do the increment of the x-axis. And what that means, as I said, what you do on this is you take the period and you divide it by 4. I'm going to do exactly the same thing as I did on the last problem. So I take the new period, 2, over 4. That will reduce to a half. So what does that mean? That means the x-axis you're going to go by halves. You're going to go 1 half, 2 halves, 3 halves, 4 halves, 5 halves, and so forth. And then those are going to be where those key points are. Yes?
So whenever we're trying to find the increment, we always divide the period
by 4. Yep. And it'll be that same way on all 6 trig functions. When we go through all the graphs, it's going to be that way. And what that does is, remember, the y's are going to be, the y values are the same. You're just moving where they are on the x-axis. Okay, so here's what we want to do now. We're going to go ahead and try to put our graph together, okay, like this now. Okay, so this is what I want you to do, is just start counting by a half. So that's 1 half, that's 1, that's 3 halves, and that's 2. Okay, now you can do that in your head. I'm just going 1 half, 2 halves, 3 halves, 4 halves. I could go out as far as I want to with that. I'm just counting by the numerator. Okay, so it goes like that. Okay, now let's go ahead on this. Since we have an amplitude of 4, what would be a good decision for your y-axis? Probably 4 and negative 4, right? So let's go ahead and go all the way up to 4 here, and all the way down to negative 4 like that. Okay? Now, I'm going to put the basic cosine graph on here only for reference. Again, you don't need to put this on here. But if you have a basic graph of y equals cosine of x, which you want to memorize, then this would go like that. That would be pi over 2, pi, 3 pi over 2, 2 pi, 1, and negative 1. Now, like basic cosine goes like this. It starts there, and then it cycles through those 5 key points like that. So the graph of what you're going to do is going to be almost the same thing. Okay? It's going to start like this. So it's going to be a 1, and it's going to go there, 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 and there. Okay? But what is the negative 4 going to do to those points? It's going to stretch it and reflect it, right? Okay? And what you can think about is you're just taking the y value and multiplying it by negative 4. That's why it's doing what it's doing. So what we're going to do now with this one is we just can kind of do this in our head. Okay, this point right here, that beginning point is going to go down to negative 4. Okay, so that's where that point goes to. The second point on a cosine is here. If you multiply the y value of this by negative 4, it's still 0, right? See, that point right there is 0 times negative 4 is still 0. And then this point here, negative 1 times negative 4 is 4. So that next point moves up like that. Okay, so that's how that goes. What I'm doing is I'm taking these y values and I'm multiplying them by -4. 1 times -4 is -4. 0 times -4 is 0, and so forth. And then the next points you can predict where they go. So that would be what the graph looks like, is like that. Okay, does that make sense? Okay, remember, when you have a number in front of the sine or cosine, it's multiplying y by that number. That's why it's stretching and reflecting. That's why. Okay, if you understand that, then it'll sink in in your mind a little bit better, I think. So that's how the graph of that goes, all right? Okay, is there any question about that? Or this is where it gets a little harder. Now I'm going to have you write down one more, and then this will be the last one I'm going to do on this section. I'm going to try to do one that puts it all together. Okay, so I'm going to do one kind of like this. Let's say that we have 2, and let's do sine. Now let's do like this. Let's do 2 times, let's see, now let me change that to something a little different this time. I'm going to try to give you a little bit of everything. Let's put a 1/2 there. And then let's put x minus, I got to think about this for a minute. Let's do like x minus 3 pi. Let me make sure that's right. Yeah, that'll work. Okay. And then out here, let's do like minus 3. Okay, let's do that one. Now, if you can put this together, then you've got it all down. Okay, so this is now trying to put everything together here. Okay, so let's do just kind of one of these. So let's start by figuring out what everything is in this problem. First of all, what's the amplitude? 2. Okay, that's the easiest part. Okay, to find the period, what do you calculate? 2 pi over that number in front of x, right? Okay, so what you're going to do is you're really doing 2 pi divided by 1/2. Okay, that's really 2 pi times 2 over 1, so that's 4 pi. Okay, so we have 4 pi as the period, and the amplitude's 2. So if you're going to do a period on this, your 5 key points are going to take place every 4 pi units. Okay, all right, how have we been finding the increment of the x-axis? Okay, take the period and divide by 4. Okay, so that's going to be period over 4. So that's 4 pi over 4. So that's equal to pi. So what does that mean? It means when we draw a graph in a minute, with the x-axis, it's going to go pi, 2 pi, 3 pi, 4 pi, 5 pi. Okay, that's real key that when you have a period change, you do that. Okay, and then the minus 3 is going to do what? That's going to take you down 3. Okay, so that's all the key ingredients that we have. And then we also have the phase shift. So what's the phase shift? 3 pi, which way? To the right. That's because it's got a minus 3 pi. That's the left-right transformation. So that's going to be 3 pi to the right like that. Okay, so that's everything that we have in the problem as we have this then. Okay, so what I'm going to do now is we're going to try to put together a graph, and I'm going to teach you how to do this in 2 steps. That's the goal. Okay, and pause me if you're getting lost as I do this. Okay, because it's kind of hard to keep up sometimes the first time you see this. So what you want to do is you want to go inside out. This is the way I'm going to teach you how to do all of the 6 trig functions graph. Is we're going to start by graphing just y equals sine of 1/2 times x minus 3 pi, like that only, okay? Because what I want you to understand, this is what you learned about functions, is when you're inside the function, this is affecting x. The period is affecting x. That's why the increment is different. The phase shift is moving stuff this way, so it's affecting x. The 2 and the minus 3 are affecting y. So you work with x, then you work with y, okay? So I want to show you how we can graph this particular thing in one step, okay? So watch carefully. First thing we want to do is the increment is pi. So that means on your x-axis, just start counting out by pi. Pi, 2 pi, 3 pi. Let's take it out a little further, like 4 pi, 5 pi, kind of like that. All right, we can just take it out as far as we want to, really. I'm just going to take it this way. You don't have to, though, okay? And the reason I'm taking it out that far is because of the phase shift, all right? So that's the increment. So this is going to be where our key values are going to fall, all right? That's really that 1/2 we've taken care of that. That gave you those numbers there. Now what is the 3 pi going to do? It's going to phase shift you, right? Okay. So here's what you want to remember right now. Now on the y-axis, let's try something like this. We have an amplitude of 2, so that's going to stretch us up to 2. Then everything goes down 3. So it's a pretty good idea maybe to do something like this. Okay, we may have to go down all the way to -5 on this, I think. So let's go all the way down to -5. Okay? All right. So this is what I want you to try to remember. Watch this one key part right here, because if you miss this, you'll miss the whole thing. Okay, if you're graphing a sine starts there. Just remember that. Sine starts at 0, 0. If it's a cosine, it starts at 0, 1. Where is that point going to go? It's going to move to 3 pi. So you always start at the phase shift if you have one. That's point number 1 right there. Okay? Point number 2 on a sine, where does it go? High point. Then back to the x-axis, low point, and so forth. So what I'm going to do from now is I just sketch in the rest of these points. It goes there, goes there, it goes there, and so forth. So that would be one cycle or one period of that graph. That's what I did. Okay, the y values aren't affected. Okay, they're still -1, 0, and 1. All right, is everybody with me there? Yeah.
What's the 1/2 do?
The 1/2 really is what changed that increment. That's what took care of that. Because remember when we did the period, we got 4 pi. That's what the 1/2 caused, is the period to change. And then the increment changed to something different.
So it's not shrinking the y values.
It's doing this actually. Actually, in this problem, it's stretching it this way. Okay, that if you have a number in front of x on any function, it does things this way, like an accordion. It's like kind of like that. Okay, all right. All right. So now the next thing we're going to do is the next stage is we're going to do the final product. So the final product is going to be y equals 2 sine of 1/2 x minus 3 pi, and then all minus 3. Okay, now this is what you want to notice on this, so you can do this. If you learn to do it this way, it's super easy to do this. So what's going to happen to this? You're going to take the y value, and what are you going to do? Multiply by 2, subtract 3. All right, and that's going to do everything for you. See, it's going to stretch it when you multiply it by 2, and then take it down 3 when you subtract 3. And you learn to do this in your head. I'll kind of write down what I'm doing. So that y value is 0. So what we're going to do is 2 times 0 minus 3. So that's equal to -3. Okay, so this point right here moves down to -3. That's where that point is now located. Okay, I go to the next one. The y value of this is 1. So I go 2 times 1 minus 3. So that's -1. So that point right there now is located down -1. Okay, like that. Okay, and then the next point that I have is this. This is 0 again. So you just do 2 times 0 minus 3. So that again is -3. So that point moves down like that. Okay, when I go to the next point, its y value is -1. So we do 2 times -1 minus 3. That one now goes to -5. So let me move this up a little bit. That point, you want to move that down to -5 like that. Okay, and then the last one is 0. So we've already done that. 2 times 0 minus 3 is -3. So that point goes like this. So the final graph is going to go through those 5 key points like that. Okay, so can you see that it moved down 3? Okay, I think that's the easy part. Can you see that it's stretched? That's a little bit wider this way, so it's double that like that. So what happened is everything just basically multiplied by 2 down 3. That's where all the points moved to. Okay, that's it. Okay, that's the easiest way I can show you how to graph these things, is just do them in 2 stages. Do the stuff inside and then outside. Work with x, work with y. You do that, you'll have it. That's the way you want to learn functions, really. That's because they're all the same. Okay, so let's go ahead and take a break, a 10-minute break. We'll come back, then we'll start on the 4-6. And what we do in that is we look at secant and cosecant and tangent and cotangent graphs. Okay, so let's take a 10-minute break. Kind of what happens with a wave. So really right now, this wave This one that's in blue here is the graph of 1.5 sine of 1130.97 t. So it's got an amplitude of 1.5, and then the period is going to be found by doing 2 pi divided by that number in front of t. So I'll explain what happens if you don't know this. A lot of times students don't know this. So what happens is the way that you make a sound louder is you do this. You change the amplitude. So the amplitude changes the loudness of something. So if I do that, it just gets louder and louder. If I want to make a sound softer and softer, I just change the amplitude like that. So that's how that goes. If I want to change the pitch, then I change the waves this way. So if you were going to make a real low pitch, like on a piano, the lowest note on a piano, it just means it stretches the waves out this way, okay? And we call that a low frequency rave because it occurs less frequently. That's why it's called a low frequency sound wave. Okay, if you want to raise the pitch, like go up to the high a note on a piano, what am I doing? I'm just making the waves more frequent. So what happens is the further you go, as the pitch gets higher and higher, the waves, the period changes, so everything is a transformation that way. Now, isn't that interesting? Okay, yeah, I mean, that's kind of how sound waves work, and that's why we know a lot about acoustics and everything. So we have learned how the sound waves can be modeled this way. And notice what happened as I was changing this, the amplitude changes and everything. So if I want to make this louder, I do that. That amplitude is now getting bigger, like that. So those are two things and how they affect sound waves, okay? The thing I was going to show you on the handout also that you might find to be interesting on here is, and this is what you get into in modern recording studios and stuff like that. Let me close this thing off here for a second and get this thing back to where it was. So the other thing I just added, because I think you might find this interesting, if you are a musician, if you've ever played a musical instrument, you might find this interesting. So actually, the note A is like on a guitar or something, your A string is 440 cycles per second. And like if you have a tuner, you tune it to 440 cycles per second. That's, you know, getting that, the period to cycle in a certain way. And then if you had like a note C sharp, okay, that would be modeled by sine of 1110 pi x. That's the note E. Now, if you're a musician, does anybody play an instrument or anything? Okay, so like if you play like a chord, a major chord is composed of 3 notes. Okay, the root, the major third, and the fifth, and it goes like this. So if you were playing an A chord, you would play A, then you would go up to C sharp, then E, and that makes a chord. So what would happen, the sound wave would just be adding all of those numbers together. So it would be this, and on this next page, this is actually what the sound wave, like on a synthesizer, for a chord would look like. And what it's done is it just added those 3 sound waves, so it looks like that now, okay? And what happens in modern studios and stuff is the sound waves can be manipulated, okay, electronically and just digitally like that. And sound waves are a lot more complicated. Some instruments are very simple, some things are very complicated. But that's kind of an idea. I thought you might find that interesting. Did you? Okay. Okay, good. Okay, that is kind of interesting. There's a lot to learn with acoustics, and that's something that I've been interested in for a long time. All right, so sine and cosine are very, very useful. You might see that if you're going to study physics some. Okay, so let's go on to the 4-6. Let me go ahead and get this started.